Welcome to Mastering Vmware's vSphere 6. This we're dealing with Chapter 12, Balancing Resource Utilization. So, we're going to be talking about things like vMotion and exploring a little bit more in depth. So, vMotion performs a live migration of a VM from one ESXi to another. And that's normally without service interruption, meaning no downtime. No connection drops, the applications stay current and running and uninterrupted. This is the entire point of virtualization, is to have your infrastructure working correctly. The premise behind vMotion is relatively straightforward. It copies the content of a VM memory from one ESXi to another and transfers control to the VM's disk file on the target host. Normally we do this with centralized storage, but essentially we live migrate the VM between both ESXi hosts so that the key point of vMotion is high availability, to keep resources or to keep critical services up. So to migrate the VM, it doesn't run for a time on either the source or destination. This is typically a short period. When we did this in our lab, we lost a packet or two, if that. So what we did was we started a continual ping on source A, and then we forced vMotion to fail over. And when it failed over to its destination, when we reviewed it, we lost one ping. So vMotion is very handy, and you can actually set it up so you have even less latency. Most client-server applications are built to withstand loss of a packet or two, so just losing a packet, not that big of a deal. Shared storage is important, whether it be a VM file system or an NFS data store, accessible by both the source and the target, source and destination. Normally you want it to be at least a gigabit, because a VM kernel port defined and enabled for vMotion has to be a minimum of at least 250 megabits per second. So, I mean, it has to be a minimum of a gigabit port, because we don't have 250 megabit ports, 10, 100, 1000, 10,000, so forth. So traditionally, vMotion migrates a running VM from one physical host to another, moving processor and memory usage. Because again, storage essentially stored, it's only moving the processor and memory from source to destination. So storage vMotion, however, will migrate the running VM's virtual disks from one data store to another data store, leaves the VM executing on the same ESXi, so you can move or migrate just the data stores. So depending on what type of vMotion you want to set up or what vMotion you want to enact, you can move different resources. vMotion and storage vMotion can be combined into a single process. That is sometimes called shared nothing vMotion. Without the need for shared storage, such as a NAS or SAN, VMware administrators can move their workloads from host to host regardless of the storage type. So this is a new feature, no longer needing centralized storage, but more latency. Because if you're trying to vMotion and storage vMotion a VM that has 500 gigs worth of data, it's going to take some time to migrate. You also have to, again, have the appropriate license for this to work. So even if the data stores are not the same, storage vMotion knows whether both hosts can see the destinated stores, and so depending on how it will migrate, will be based off of what it can see. Normally, again, we do shared storage to kind of help prevent issues. We can also share vCENTERs across the internet or across a WAN. With vSphere 6, You can migrate VMs across clusters, virtual standard switches, distributed switches, and vCenter servers. Motion can now provide some disaster avoidance, not disaster recovery, but a disaster avoidance capabilities across larger distances, meaning you can have it fail over across a WAN. Normally, this cross vCenter deployments, you have to have a heartbeat of at least 150 milliseconds or less, no more layer 2 boundaries. It can now go to a layer 3 boundary, again, the internet. vCenter must also be part of the same single sign-on domain, same part of the overall single sign-on administrative functionality of vCenter. Let's get more into the distributed resource scheduler. So our distributed resource scheduler, DRS, is a feature of vCenter that has two main functions: to decide which node of a cluster should run a VM when it's powered on. This is called the intelligent placement, and to evaluate the load on the cluster over time and either make recommendations for migration or use vMotion to automatically move the VMs when it sees it's necessary. Basically, it controls what server is going to have what VM running and where they should be located. They're going to move based off of its understanding of trends. That way it can kind of predict kind of future loads, and that was more of a far stretch. Not so much future loads, but it learns from past trends how it should work and how it will work best currently. DRS checks every 5 minutes or every 300 seconds to see if the cluster workload is balanced, and it can actually balance it if it's not. DRS also invokes by certain actions, such as adding or removing ESXi hosts or changing resource settings on a VM will cause a DRS update. DRS will calculate imbalances of clusters and then may apply resource controls to kind of help bring them back into balance. You can do this manually, partially automated, or full automated. So manual DRS, every time you power on a VM, the cluster prompts you to select the ESXi where the VM should be hosted. Suggests vMotion migrates when the appropriate DRS detects an imbalance, all manually. Partial automation, the initial placement is automated, but migrations are still manual. They'll prompt you. Full automation allows for fully automated portions. The first 5 positions, the values of the sliding bar range from conservative to aggressive, meaning how you actually want to be able to balance it. Aggressive is going to use more resources. Conservative automatically applies recommendation ranks as priority and only does recommendations. With the slider all the way over to the aggressive setting, any imbalance in the cluster will cause the recommendation to automatically be approved. So you can distribute this based off of certain priorities. If you actually want it to be more conservative, it will only move high priorities. If you want to have this more aggressive, it will actually look at any of the imbalances and move them appropriately. vSphere DRS supports 3 types of scheduling. VM affirmative rules keep virtual machines together. VM anti-affirmative rules separate VMs, and host affirmative rules, virtual machines to hosts. So here the Windows VM is in a group that is a member of 2 different host affinities. As a result, the VM can only run on a host that satisfy both rules. DRS VM overrides. So most VMs should be allowed to take advantage of DRS balancing, but you may find that certain enterprise critical VMs aren't really good for distributed scheduling. So you can actually set which ones can and cannot take advantage of this. These VMs should remain in the cluster to take advantage of things like high availability, high fault tolerance, and VMOTION, but not so much DRS. You can do DRS VM overrides based off of the automation level. Again, fully automated, partially manual, cluster, or disabled are the default options. So working with our storage, DRS builds on functionality of the storage I/O and storage vMotion. They provide the ability to perform automated balancing of the storage. Like vSphere, DRS also has storage DRS and is built on some closely related concepts. Storage DRS uses data stores and clusters as collection of data stores as it acts. Storage DRS also performs the initial placement of the VM hard disks and ongoing balancing of those hard disks. Lastly, storage DRS offers the VM hard disks the affinity and anti-affinity functionality. That's actually the resource allocation in a nutshell. Thank you.